What kind of technology can forge parts for jets, electric vehicles, and turbines with near-surgical accuracy? It's not something you can do with ordinary equipment. Here are 5 extreme forging machines you truly won't believe exist. Number 5. VIVA Forging Company's Modern Forging Plant. Deep in the heart of Central Europe sits a forging facility that most people have never heard of, yet it produces components that keep the world moving. VIVA operates one of the most sophisticated forging operations on the continent. What makes VIVA special isn't just raw power. It's the combination of brute force and precision. Their forging presses handle advanced steel alloys that most facilities won't touch. Materials so demanding they require perfect temperature control within narrow windows measured in seconds. The heating systems are automated, moving glowing metal billets that could melt through concrete if mishandled. These machines specialize in complex geometries, parts with intricate shapes that push the boundaries of what forging can achieve. The automotive sector relies on VIVA for components that must withstand extreme stress, while maintaining perfect dimensional accuracy. Energy companies trust them with parts that operate in hostile environments where failure isn't an option. The production control systems running these machines represent next-level manufacturing intelligence. Every parameter gets monitored, every measurement recorded, creating a digital fingerprint for each component. Before we jump into number 4, if this kind of extreme engineering already has you hooked, hit that like button. And if you want more breakdowns just like this, make sure you're subscribed. The next machines only get crazier. Number 4. Hatebur AMP 70 Mechanical Forging Press. The Hatebur AMP 70 represents over a century of Austrian engineering excellence compressed into one mechanical masterpiece. This press doesn't just apply force. It thinks about how it applies force. The adaptive stiffening technology actively reduces machine deformation during operation, meaning the press maintains precision even when generating massive tonnage. The automotive industry has made the AMP-70 their workhorse for high-runner parts, components produced in massive quantities where consistency matters more than almost anything else. But here's what separates this machine from competitors. Its operational availability borders on legendary. While other presses require frequent maintenance and adjustment, the AMP-70 just keeps running, shift after shift, year after year. The robust design philosophy behind this Austrian marvel prioritizes longevity without sacrificing performance. Every component gets engineered for the long haul, every system designed with redundancy and reliability in mind. Number 3. Thyssenkrupp's 16,000-ton forging press. 16,000 tons of force. To put that in perspective, this single machine applies pressure equivalent to the weight of nearly 3,000 cars pressing down simultaneously. Located in Hamburg, Saarland, this mechanical monster stands almost 15 meters tall and weighs 1,700 tons before it even starts working. The press dominates the production floor, a towering testament to German engineering ambition. But size alone doesn't tell the story. This beast produces 360,000 forged parts annually, each one meeting exacting specifications despite the breakneck pace. The automation and digitization integrated into this operation represents manufacturing's future happening right now. Sensors monitor every aspect of every forging cycle. Digital systems predict maintenance needs before failures occur. The entire production line operates with machine learning algorithms optimizing processes in real time. Thyssenkrupp built this facility with future mobility in mind, particularly electric vehicle components that demand different material properties than traditional automotive parts. The press handles everything from truck chassis components to specialized parts for next-generation transportation systems. This isn't just a machine. It's infrastructure for an industry in transformation. Number 2. DANGO Dienenthal Open Die Forging Press with Advanced Manipulator Systems. DANGO Dienenthal builds open die forging systems that handle workpieces so large and so heavy, they require robotic manipulation systems. The rail-bound manipulators transport forgings weighing up to 3,500 kilonewtons with positioning accuracy that defies belief. These aren't crude industrial robots pushing parts around. They're precision instruments conducting a carefully choreographed dance with metal heated to temperatures that glow bright orange. Here's where it gets fascinating. What determines forging quality most often isn't the press itself, but the manipulation between press strokes. How you rotate the workpiece, how you position it for the next hit, how you maintain temperature uniformity. Dango and DIENENTHAL understood this and engineered their manipulator systems with the same obsessive attention to detail as the presses themselves. The mobile manipulators efficiently transfer workpieces between furnaces and presses, critical when working with materials that have extremely narrow temperature windows. High alloy steels and titanium don't forgive mistakes. Drop below the correct temperature range and the material becomes unworkable. Exceed the upper limit and you've just created expensive scrap. This system's integrated documentation records every parameter of every forging operation. In the aerospace and energy sectors, traceability isn't optional. When a turbine blade fails, investigators need to trace that component's entire manufacturing history. Dango and DIENENTHAL systems provide that documentation automatically, creating digital twins of physical parts that live in databases long after the components enter service. The process safety and productivity gains from this level of automation transform economics for manufacturers. Parts that previously required multiple heat cycles and extensive machining now emerge from the forging process near net shape, requiring minimal finishing. Time from billet to finished component drops dramatically while quality and consistency improve. But what happens when you forge titanium at the wrong temperature? Titanium represents one of forging's greatest challenges, and the answer to what happens with incorrect temperature control reveals why these extreme machines matter so much. Forge titanium too cold, and you're not actually forging it. You're trying to bend a material harder than most tool steels. The press applies its full force, and the titanium either cracks catastrophically or barely deforms, wasting energy and potentially damaging equipment. But forge titanium too hot, past its beta transist temperature, and the metallurgical structure transforms in ways that destroy the material's desirable properties. The fine-grained structure that gives titanium its incredible strength to weight ratio coarsens, creating weak points that won't appear until the component faces real-world stress, possibly years later during service. The temperature window for optimal titanium forging spans only about 100 degrees Celsius, and the material must stay within that window throughout the entire forging sequence. This means heating systems must compensate for cooling that occurs during manipulation and between press strokes. Advanced machines like those from SMS Group and DANGO and DIENENTHAL monitor temperature constantly using infrared sensors and adjust process timing automatically. Human operators simply cannot react fast enough to maintain control at this level. This is why aerospace manufacturers demand specific machines for titanium work, and why those machines cost many millions of euros. If you're enjoying seeing how these machines actually shape our world, drop a like, it really helps. And don't forget to subscribe so you never miss the next deep dive into engineering giants like these. Number 1. SMS Group's SMX Hydraulic Radial Forging Machine. This isn't just the best machine on our list. It's arguably the most sophisticated forging technology currently in production anywhere in the world. Radial forging differs fundamentally from the hammer and anvil approach most people picture. Instead of one massive downward strike, radial forging uses multiple hammers arranged around the workpiece, striking in rapid succession from all sides. The result is more uniform deformation, better material properties, and surface finishes that approach machined quality straight from the forge. The SMX achieves this through a compact hydraulic drive system featuring dual pumps, an integrated flywheel, and frequency inverter control. This sounds technical, but the implications are profound. The dual pump setup allows the press to adjust its power output in real time, delivering exactly the force needed for optimal deformation at each moment in the process. Not maximum force, optimal force. This precision control produces forgings with reproducible, traceable properties that require minimum remachining. In aerospace, where components might undergo 100 hours of machining for every hour of forging, Reducing that machining time even slightly saves enormous costs. The SMX delivers components so close to final dimensions that subsequent machining operations turn into finishing touches rather than major material removal. The automation goes beyond anything we've discussed so far. These machines operate essentially without human intervention once programmed. The manipulators handle workpieces weighing tons with gentleness that seems impossible, positioning them for each forging pass with repeatability measured in fractions of millimeters. But why can't American or Asian manufacturers build machines as good as these? Well, they absolutely can and do build impressive forging equipment. But European manufacturers, particularly German ones, maintain advantages rooted in industrial history and engineering culture that prove difficult to replicate. Germany's forging machine industry emerged from centuries of metallurgical tradition combined with post-World War II reconstruction that rebuilt manufacturing from the ground up using the latest technology. Companies like SMS Group, DANGO and Dienenthal, and Thyssenkrupp invested consistently in research and development even during economic downturns, treating advanced manufacturing as strategic national infrastructure rather than just private enterprise. The engineering education systems in Germany and Austria produce specialists who combine theoretical knowledge with hands-on apprenticeship experience in ways American and Asian systems often don't match. A German forging press designer likely spent years working with actual machines on factory floors before ever touching CAD software. This creates intuition about machine behavior that pure academic training can't replicate. So if you could choose one of these machines to operate for a day, which would you choose and why? Drop your answer in the comments below. And if you found this video fascinating, hit that subscribe button because we're just getting started exploring the machines that make our modern world possible. Until next time.